So the question is, sketch the root locus of the system whose open loop transfer function is g of s equal to k divided by s into s plus 2 into s plus 4. So we have to sketch the open loop transfer function of the given system, where the system is having unity feedback. Hence we can say that h of s is equal to 1. Since it is having unity feedback, h of s is equal to 1. Okay, so we have open loop transfer function. Since h of s is equal to 1, we have open loop transfer function g of s. It is given as k divided by s into s plus 2 into s plus 4. So what are the poles? Open loop poles. Open loop poles equal to s is equal to 0, comma minus 2, comma minus 4, because these are the this is the denominator. Hence the open loop poles are s is equal to 0, minus 2 and s is equal to minus 4. So what are the number of open loop poles? Number of open loop poles n is equal to 3 here, and here you can see that there are no open loop zeros, only gain in the denominator k, open loop gain in the denominator, k is in the denominator, and hence we can write that m is equal to open loop poles, m is equal to 0. So the first step is locate all open loop poles and zeros in the S plane. So before that we have to mark the graph sheet. So the first step is to mark all poles and zeros, all open loop poles and open loop zeros in the S plane. So we have to locate all poles and zeros. Here we can see that there are no open loop zeros, only there are poles. So the poles are at s is equal to 0. So we can mark the poles here, open loop poles here, at s is equal to 0. That is one pole. Then another pole is at s is equal to minus 2. And another pole is at s is equal to minus 4. So first step is to mark all open loop poles and zeros. Now we can see here that there are 3 open loop poles and finite poles, and there are no finite zeros. That means number of root locus branches equal to 3, and since there are no finite zeros, all 3 branches will end at 0 or zeros at infinity. Since there are no finite zeros, these all 3, the root locus branches starting from all these 3 poles will end at zeros at infinity. So the next step is we have to find out the asymptotes and centroid, because there are 3 number of poles and 3 root locus branches. one branch that starts from minus 4, that is ending to infinity, here negative real axis, and the two other root locus branches that should also ends at infinity, that will do so along with the asymptotes. So, how can we find the asymptotes? So, the equation for angle of asymptote is plus or minus 180 into 2q plus 1 divided by n minus m, where q is equal to 0, 1, etc. up to n minus m minus 1. Where q is equal to 0, 1, 2, etc. So, by applying the equation, we will get, if q equal to 0, angle of asymptote will be, angles will be plus or minus 180 by 3, that because n minus m equal to 3, n equal to 3 and m is equal to 0, and angle is equal to plus or minus 60. If q equal to 1, then angles will be plus or minus 180 into 3 divided by 3, that will be plus or minus 180 itself. Then if q is equal to 2, angles will be, if you substitute for q is equal to you will get plus or minus 300, that is actually is equal to minus plus 60, plus or minus 300 degree is equal to minus plus 60 degree. So, these are the angles. So, if you do continuously, you will get either plus or minus 60 and plus or minus 180 as angle of asymptotes. In this, plus or minus 180 is actually the asymptote here. That is, we have already have a root locus branch that starts from minus 4 and end at infinity, that goes asymptotically in the angle plus or minus 180 degree. Okay. So, this is the angle this is the root locus branch corresponding to plus or minus 180 degree. So, because this one is starting from here and it asymptotically goes to infinity at an angle plus or minus 180 degree, because it is on the negative real axis itself. So, the other angle, that is plus or minus 60 degree or minus plus 60 degree, both are same. So, that will be corresponding to this the root locus branches starting from minus 2 and minus 1. Okay. So, the next step is to find the centroid. As I have already told you, all asymptotes will meet at the real axis, that is called centroid. So, we can find, the next step is we can find the centroid by using the equation centroid equal to sum of poles minus sum of zeros by n minus m. So, what are the sum of poles here? Sum of poles are at 0 plus next pole is at minus 2, next pole is at minus 4, minus sum of zeros, there are no zeros, so you can put at a 0 here. Now, n minus m is 3. So, the centroid will be minus 6 by 3, that will be at minus 2. So, the asymptotes will meet at the centroid minus 2. So, what we have to do? We have to mark the centroid and asymptote in the graph sheet. So, So your minus 2, that is the centroid. We can mark it here. Minus 2 is the our centroid, and from this centroid we have to mark the asymptotes. So asymptotes, how can we mark the asymptotes? From the centroid, take the angles plus 60 and minus 60 and plot that angles from the centroid. So from plus 2, mark an angle, from plus 2 mark an angle that is plus 60. Okay, so mark an angle plus 60, that is corresponding to plus 2. So this value is plus 60, this is asymptote. So this value is 60 degree, plus 60 degree. Now from this value, mark another angle minus 60. From the centroid, mark another angle minus 60. Mark another angle, that is minus 60 in the graph sheet. So we got angle of asymptotes plus 60 degree and minus 60 degree, and the centroid is plus 2. Centroid is at minus 2. By using the equation, we got centroid as minus 2. So the next step is to mark the centroid and mark the angle of asymptotes. Now two root locus branches that starting from minus 2 and 0. Okay, the two root locus branches that starting from minus 2 and 0 will go to the pole at infinity asymptotically. Okay, the asymptotes are given here. So these two root locus branches will end at the will end at the 0 at infinity, and it will, the path of that root locus branches will be asymptotic to the given or these asymptotes. So the next step is to find the breakaway and break-in points. So in order to find the breakaway or breaking points, we need to find the characteristic equation of the given system. So the next step is to find the breakaway or break-in points. So we have the two poles are coming here. We can see that minus 2 and 0, two adjacent poles are here. So from each of these poles a root locus branch will be there. So the point will be, if two adjacent poles are coming, the point will be breakaway point. If adjacent poles are coming, the point will be breakaway point. Since minus 2 and 0, these are adjacent poles, the point will be breakaway point. two adjacent poles are coming, hence the point will be breakaway point. That means two root locus branches starting from -2 and 0 will meet at some point and it breaks away to the 0 at infinity. Now, in order to find the breakaway point, we have to find the characteristic equation of the system. So, we can write C of s by R of s, closed loop transfer function of the system, that is equal to, apply the formula G divided by 1 plus G of s H of s. Here H of s is equal to 1, then s into s plus 2 into s plus 4 plus k. So, the characteristic equation of the system is s into s plus 2 into s plus 4 plus k equal to 0. On expanding it, we can write the equation as s cube plus 6s square plus 8s plus k equal to 0. Now, as I have told in the rules of root locus, we need to find the equation with respect to k and find dk by ds. So, we have an equation, we have characteristic equation here. So, from the characteristic equation, we can write that k is equal to minus s cube minus 6s square minus 8s, and in order to find the breakaway point, find dk by ds, that is in the equation of, find the equation of k, find the first derivative of it with respect to s, that will be, the equation will be minus of 3s, sorry, these all are pluses, minus s cube plus 6s square plus 8s. So, the equation dk by ds will be minus 3s square plus 12s plus 8. Now, equate it into 0. Okay. Now, equate it into 0, that is minus of 3s square plus 12s plus 8 equal to 0. Now, if we equate that equations into 0, our equation will be changed into, 3s square plus 12s plus 8 equal to 0. On solving the quadratic equation, we can find s is equal to minus 0.845 or minus 3.154. So, we have two values for us. We have to check whether which value of this as breakaway point. Okay. If we got two values here, we need to check which value of this comes as breakaway point. So, in order to do that, substitute the value of this s in the equation of k and check whether its value is positive or real. That is, we have the equation for k as minus s cube plus 6s square plus 8s. In this equation for k, substitute for s is equal to minus 0.845. Okay, in this equation, substitute for s is equal to minus 0.845. Then check whether we got the value of k as positive real one. So, if we substitute this, we got the value of k as 3.08. It is a positive real value, and real value. Hence, the breakaway point is at s is equal to minus 0.845. Okay, since we got at s is equal to minus 0.845, when we substitute it in the equation of k, we got k value as positive and real, hence the breakaway point is minus 0.845. Now, if we substitute S value as minus 3.15, you will not get the K value as a positive value, it will be a negative value. If we substitute for S is equal to minus 3.15, we will get the K value as a negative value, hence it is not a breakaway point. So, there is only one breakaway point and it is at S is equal to minus 0.845. Now, no need to do all these calculations, because if we find two values of S, we already know there is one root locus branch starting from minus 2, other root locus branch starting from 0. So, the breakaway point will be always in between this 0 and minus 2 with respect to this question. Okay. So, one root locus branch is starting from minus 2, other starting from 0. So, always the breakaway point will be in between these two values. So, here there are only two values, minus 0.84 and minus 3.15. You can see that the minus 3.15 is outside the root locus, okay, because it is outside the value of minus 2. So, here the breakaway point is minus 0.845. So, we can mark that point here, mark the breakaway point here. Approximately here, mark the breakaway point. Breakaway point. Now, we can draw the root locus as a branch that starts from minus 2 starts from minus 2, that is one branch, starts from 0, that is another branch, that will meet approximately here at breakaway point, that will meet at breakaway point here. Okay, this is breakaway point, and breakaway point means the point here, the root locus branches, two root locus branches starting from minus 2 and 0 will meet here, and from here it will ends or break away and it ends to a 0 at infinity. So, from this point one branch will goes asymptotically to this asymptote, and another branch, that is one branch will goes asymptotically in this direction, another branch that will goes asymptotically in this direction. So, this is the root locus corresponding to the given problem. So, one branch starts from minus 4, it ends at the 0 in the real axis. Another branches, two branches, there is a breakaway point in between 0 and minus 2. These in between 0 and minus 2 is a part of root locus. The real axis segment is a part of root locus. Two branches starting from here meets at the breakaway point, and it will diverge and goes asymptotically, and it will ends at a 0 at infinity. So, these are the root locus. This is the root locus corresponding to the given problem.